In topic 5-7, again, we're going to learn how to divide with a two-digit divisor. Now, understand that this symbol takes place of this symbol. They both mean to divide. But before we do that, you need to first estimate. So, remember, with the divisor, you can estimate it, say to 80. But don't forget, we have to use compatible numbers. And 8 can go into 46, so we can make it go into 4600. And cross out the zeros. And 8 goes into 46 6 times. Circle your answer. So you know that your estimate needs to be close to just 6. So when it's written in this form, you have to make it look like long division form. So just write 462 divided by 77. So we ask ourselves, can 77 go into 4? No. Can 77 go into 46? No. How many times can 76 go into 462? As I said before, I would take the first digit and ask it how many times will it go into this digit without going over. So 6, actually 7 times 6, because 7 times 7 is 49. That's too big. So let's try 6. 6 times 7 is 42. Carry the 4. Again, if you can't multiply this way, just rewrite it on your paper from top to bottom, but close to the problem. Just like this. 6 times 7 is 42, plus 4 more is 46. And subtract, there's no remainder. So my estimate was exactly that of the estimated one. Okay, on the next one, I want you to write these problems down. I should have had you write them all down with spaces, enough space so you could do the work. So do that now. Now, you need to estimate first, circle your quotient, and then write this out because it's in this format. We have to make it in long division format and get that quotient as well. Push pause and see what quotient you get. Okay, so I'm going to rewrite my estimate over here. I'm going to make 68, I'm going to estimate it to 7D. Okay, now I can write it this format because that's just like what we did in topic 5-2. So let's look at these two and try to make it compatible to 7. And that would be I wrote the wrong thing. Sorry about that. It is 5600. So cross out the zeros. 7 goes into 56 8 times with 1 0 left. So my estimated quotient is 80. Now let's find out what the real quotient is. Not the real, the actual one. And divided by 68. So we ask ourselves, can 68 go into 5? No. Can 68 go into 55? No. How many times can 68 go into 557? So I'm going to underline that digit, underline these two digits, and say, how many times can 6 go into 55 without going over? That would be 9 times. But I can tell you right now, 9 times 6 is 54. But you're going to have a lot to carry over, and it's going to go above 55. So let's try 8. Let's see if that works. So 8 times 8 is 64. Carry the 6. 8 times 6 is 48. 48 plus 6 is 54. You subtract. You get a 1, you get a 3, and then bring down the 8. Now, how many times can 6 go into 13 without going over? Well, that would be twice. Let's try that. Two times 8 is 16. Carry the 1. 12, 13. Subtract. And I get a remainder of 2. Is 82 remainder of 2 close to my estimate? Yes. Did you get those two answers? Great job.
I love you guys.
All right, let's go to this one. This one is 777 divided by 21. Okay. Push pause. Give me your estimates and give me the actual quotient. All right, I'm going to estimate 21 to 20. And I'm going to estimate that. Now, you could estimate it to 800, but you could just change 77 to 78, add a 0. Cross out the zeros. 2 goes into 7 3 times. That leaves 1 left over. 2 goes into 18 6 times. So you could have had 36 or 40, but my estimate is going to be pretty close to my actual, closer to the actual answer than 40 is. But if you got 40, I'd accept that. So now in the actual one, 21 can't go into 7. We'll put an X above the 7 in the hundreds place. Can 21 go into 77? Yes. How many times can 2 go into 7? Well, 4 times 2 is 8. That's too big. 3 times 2 is 6. So we'll use a 3. So that is 63. Subtract. You get 14. Bring down the 7. How many times can 21, well, I forgot to bring down the 7. How many times can 2 go into 14? That's 7 times. 7 times 1 is 7. 7 times 2 is 14. Subtract. There is my actual quotient, 37, which is pretty close to my estimated answer. Did you get that? Great.
I love you guys.
Let's move on to this problem. Go ahead and push pause. Give me the estimated quotient and the actual quotient. Okay, so 45, I am going to estimate to 50. And then 98,000, I'm going to estimate to 10,000. 3 zeros. Cross out the zeros. 5 goes into 10 twice. And you're left with 2 zeros. So my estimated answer is 200. All right. So let's rewrite this to 9,855. I apologize for my numbers. It's very hard to write on a mouse. And then we get 45. So obviously my first digit's going to be in the hundreds place, but can 45 go into 9? No. How many times can 4 go into 9? That would be twice. 2 times 45 is 90. Subtract. 8 minus 0 is 5. So bring down the 5 in the tens place. Well, if 2 times 45 gave me 90, that's going to be too big. So we're going to have to use 1. 1 times 5 is 45. That leaves 8 minus 4, which is 4. 5 minus 5 is 5. 40 is less than the divisor, so we're good. So now we need to bring down the last 5. And how many times can 4 go into 40? That would be 9 times, or 10 times. So we can't fit 2 digits in one place value. So we'll go to the highest single digit, which is a 9. 9 times 5 is 45. Carry the 4. 9 times 4 is 36. 36 plus 4 is 40. So we subtract. We do not get a remainder. And our answer is 219, which is pretty doggone close to our estimate. If you got that, awesome job.
I love you guys.
Okay, on this second to last problem, go ahead and estimate it first and then find the actual quotient. Okay, so 13, I'm going to estimate we can estimate it to 10. And we're going to divide it. Now we got to look at this and say, what can we change that to? I guess the closest one we can really do is 2,000. Cross out the zeros. 200 divided by 1 is 200. So we got another one with an estimation of 200, just like we did right here. So obviously our first digit is going to go above the 7 in the hundreds place. Can 13 go into 1? Nope. Can 13 go into 17? Yep, one time. So 7 minus 3 is 4. Bring down the next 4. Well, how many times can 1 go into 4? That would be 4 times, but I can just tell it's going to be bigger. So let's go with 1 less, which would be 3. 13 times 3 is 39. You got to take one set from there. 10 plus 4 is 14. 14 minus 9 is 5. And obviously, 5 is less than 13. So we're good. So let's bring down the 8. How many times can 13 go into 58? Let's make it 5 times. 5 times 3 is 15. Carry the 1. 5 plus 1 is 6. Too big. So, erase this. I'm going to erase this. So I know 5 was too big, so let's go to the next smallest number, which would be a 4. That would be a 12. Carry the 1. 4 times 1 is 4, plus 1 is 5. And 8 minus 2 is 6. So it's 134, remainder of 6. Now 134 is not that close to 200. So I wonder if we could have done something different. I don't see it to make it compatible, because we underestimated 13 to get to 10, and we overestimated 1,700 to make it compatible with 20, which would make 2,000. I don't know. Wonder if we would have done well, I guess we could have, instead of making it 2,000, we could have made it 1,500 divided by 10. Yep, I think that's what we should have done. We should have made 17 to 15 instead of 17 to 20. Cross out the zeros, and that would make it 150, which that seems the better estimate than 134. So I apologize, because 17 is closer to 15 than it is. And actually, we could have, because it's multiple of 10, we could have just left 1,700. 1,700 too. Cross out the zeros, but that would make it 170. So, because we underestimated the divisor, we should have underestimated the dividend as well. So this is still kind of far away, so this would have been a better estimate. That one was a tricky one, I have to admit that. But we did have a remainder. But so if you got one of those, that's great. If you got 1,500 divided by 10, then you really did a great job with the estimation, because I didn't come up with it first. I just know my actual quotient was way larger. I mean, way smaller than my estimated. All right, if you did that, as long as you got the actual answer, you did a great job.
I love you guys.
All right, here's the last problem. Okay, go ahead and estimate first, and then find the actual quotient. All right, so here we go again. We have 12. So if we estimate 12 and we take it down to 10, then I am going to leave 7,073 as 7,300. Cross out the zeros, and that leaves an estimated quotient of 730. All right, so that's a big number. All right, let's rewrite this for long division. 7,308. We divide it by 12. Now, I will have to say this, back to the estimate. If you left it as just 12, and you know in your head that 12 can go into 72, then by all means, you could do it that way as well. 12 goes into 72 6 times, and then you're left with 2 fat zeros, which gives you the estimated quotient of 600. Now notice the difference from dropping 12 to 10, and all we did was go from 8 to 0, and look at our estimated quotient, and not doing anything to 12, going down 100 this way to 7,200, and our difference in just our estimation is almost 130. So let's see what we get as our actual answer. Can 12 go into 7? No. How many times can 12 go into 73? Well, I know 1 can go into 7 times, but that's going to be too big. So let's go with a number smaller and go with 6. 6 times 2 is 12. 6 times 1 is 6, plus 1 is 7. 3 minus 2 is 1. Bring down the 0. Now, obviously 6 times 12, 72. That's how we got that. All right, so how many times can 12 go into 10? It can't. And as soon as you say it cannot, it can go in at 0 times. So now we got to bring down the 8. How many times can 12 go into 108? Well, let's see here. 9. So let's try 9 times. 1 goes into 10. Can't fit 10. So we're going to try 9. 9 times 2 is 18. 9 times 1 is 9, plus 1 is 10. So 108 minus 108 is 0. So our estimated answer is 609. So obviously this was the better estimate, because 609 is pretty far away from 730. But if you did do that as your estimate, just understand that you can see that 12 can go into 72. So this is really the better estimate, because this really doesn't help you to your actual answer. This one definitely does. But that one was also another tricky one. The first 4 were pretty easy to do. But anyway, if you got the actual answer of 609, great job. I'll see you tomorrow in school.